My dear students, other viewers and listeners, I, Professor Manohar Lal, School of Computer and Information Sciences, welcome you to this lecture on uncertain knowledge and reasoning. Especially will focus on fuzzy logic, why and what. Friends, before I go into the details of the subject, I'd like to tell why we study whatever is going to be discussed today. Friends, the topic falls under artificial intelligence. And we know from our previous lectures that artificial intelligence is meant to solve hard problems, especially which are exponentially hard, by exploiting the knowledge of the domain under consideration. Hence, knowledge plays a very important role in solving problems through AI tools and techniques. Rather, it is said that knowledge is fodder of artificial intelligence or even general intelligence also. So friends, in this context, the role of knowledge is very important so far as solving problems with the tools and technique of artificial intelligence is concerned. Now within that, why we study uncertain knowledge and reasoning and particularly fuzzy logic? The reason is that the knowledge whatever we get is uncertain on the basis of the following facts. Number one, that whatever is stated as a fact, it generally is a sort of belief. Earlier the earth was sort of thought of as the center of the universe. It was a belief, and on the basis of this, a number of problems were solved. However, later on, Galileo and others told us that earth is not the center of the universe. Rather, earth is revolving around the sun and so on and so forth. So, we have another set of beliefs. So whenever we advance in our thinking, we have newer and newer set of beliefs. We cannot say with surety that this is a fact, this is a set of facts. So most of the time whatever we are reasoning, whatever we are solving problems with is generally a set of beliefs. And beliefs are revisable, as I told you just now, that earlier the center of the universe was thought of as the earth. It was later on revised, and it goes on. Similarly, in our everyday experience, when we get better and better experience, we revise our beliefs which get sharpened, and those get sharpened in order to solve problems better. So friends, the very first thing of uncertainty in knowledge is our beliefs, because those cannot be certain. Secondly, when we are dealing with other things like mass phenomena, for example, when we say an Indian is of height 5 feet 6 inches. Now height of the person is a variable which varies from person to person over billions of people. So in such cases, in order to have a general idea whether an Indian is taller than an American or a Chinese or not, what we do, we take a sort of average, some sort of average over the people concerned, over a mass phenomena, and in this way we say, for example, the height of a person, an Indian, is 5 feet 6 inches. Actually we mean here that the average height of an Indian is 5 feet 6 inches, and if we go to measure the height of various people, I think none may be having height 5 feet 6 inches, but the average comes out of that. This is the second reason of uncertainty in the knowledge, because when the mass phenomena is involved, in that case we have to represent the masses by single numbers, etc., and that tells us to approximate it, to approximately represent by average or something like that. The third cause of uncertainty in knowledge is that we are using natural languages for communication and other purposes. Language is a very strong tool with the human beings because that makes us the distinct from the other species, living species like that. Language is a strength, and language, particularly natural language, have another strength that just by one word we may be denoting a number of concepts. For example, we take the concept of tall. Now, a person in Indian context who is say above 5 feet 10 inches or so may be called tall. But then a person of height 5 feet 11 inches, a person of height 6 feet and a person of height more than 6 feet is also tall. So in this way, the single word tall represents a number of heights each greater than or equal to 5 feet 10 inches. Similarly, there are everyday other concepts or adjectives, for example, sweet, beautiful, and so on and so forth. Now, the use of these words is definitely a strength, but at the same time, it inserts an uncertainty also, in the sense, when I say Mohan is tall, it inserts an element of uncertainty in the sense we cannot say whether Mohan is 5 feet 10 inches, whether Mohan is 5 feet 11 inches, whether Mohan is 6 feet or Mohan is more than 6 feet. On one hand, the use of tall is a strength in the sense that single word tall denotes a large number of heights. On the other hand, when solving a problem with the computer system, it creates a problem because such words which are actually linguistic variables, that is, they are variables, they may assume different values and all that, have to be resolved in some situations. The uncertainty because of such linguistic variables may require to be resolved in some situations, and in essence, I have told you, whatever I have said, I just briefly summarize, that in order to solve difficult problems, we require knowledge. However, the knowledge whichever we use is generally based on the basis of beliefs which are revisable, on the basis of averages, in the case of mass phenomena which are also not precise, and thirdly, we use linguistic variables like tall, hot, sweet, etc. So all these reasons tell us the knowledge which we are using in solving problems is not certain, and therefore it is very important for us to study the uncertainty in knowledge, number one, and number two, how to formalize it, how to express it in mathematical concepts like sets, numbers, relations, functions, etc., so that the computer also can simulate the human behavior in solving the problems, because computer can work only on those concepts and on those operations which are directly or indirectly mathematical in nature. So we have two goals, because of which we study uncertainty of knowledge and reasoning, because most of our knowledge is uncertain. However, it needs to be formalized in terms of mathematical entities like sets, relations and functions in order to be operable by computer systems, because it is a man-machine combination which solves problems. Man, on one hand, perceives the problems, number one. Number two, it also plans the solution of the problem. That is, what steps are to be executed by the machine are also thought of by some human being at some stage and are embedded in the machine. And this also raises the question, then what is the role of the machine? What is the role of the computer system? If it is the human beings which solves the problem, at least the plan of the problem is given by the human being because of the executional speed. Computers are used mainly because the speed of the computer systems is much, much faster as compared to that of human beings. So this man-machine combination solves problems, and we know most of the knowledge which is experienced by human beings is to be embedded in machine, and machine requires the embedding in terms of mathematical concepts like numbers, sets, relations and functions. So friends, with this background, let us come to the precise details of our today's talk. So please look at the next slide. Next slide only says why we use, what is the rule of solving difficult problems. I may again emphasize, I may recall briefly that the usual technique of solving problems in computer science is algorithm. However, during 1930 and 1940 it was proved that only a very small fraction of the problems which we human beings encounter or may encounter in the future also, only a very small fraction of such problems will be solvable with algorithmic means, and therefore we have to take resource to other methods which may not be just purely algorithmic. Then it was found out in the very beginning, in the initial stages of the computer revolution, that knowledge is an essential component, as I mentioned earlier also. So in order to solve those problems which are said to be hard problems, that is, which take much more time as the size of the problem increases, which may not be responding in reasonable amount of time, and many of those may not be solvable at all with the computer systems. For such problems, if we exploit the knowledge of the domain under consideration, then some of those may become solvable. So that is exactly the role of knowledge in solving problems. Please look at the next slide. The next slide says that the knowledge may be complete and may not be precise, etc., because of the fact that universe is vast, and secondly, it has changed over billions and billions of years since the birth of the universe. So the change has inserted element of uncertainty, because the change is infinite dimensional almost, and the universe is too big to comprehend for us. So because of that, the complete certain knowledge is impossible, and this is why we study the topic of uncertain knowledge. Next slide says, uncertainty types include, friends, uncertainty may be of three types mainly. One is epistemic, the other is probabilistic, and third is fuzzy. I have already given you an example that epistemic means degree of belief. As the next example says, that Mohan believes that an American is tall. Mohan believes that an American is tall. Now there are at least three words which are having some uncertainty, which insert some uncertainty in the statement Mohan believes that an American is tall. First of all, believes. We don't know how much is the strength of belief of Mohan. Mohan may be partially believing. Mohan may be just believing. Mohan may be completely believing. So there are shades of belief, shades of degree of faith of Mohan in the statement which is being made. Then the next is American. Now here also, American is again an imprecise word so far as tallness is concerned. Some of the Americans may be even 7 feet tall. Some of the Americans I have seen myself are less than 5 feet also. So what I mean to say, American in itself is an uncertain word vis-a-vis height of a person is concerned. Then tall. So I have already explained the word tall stands for a large number of heights. So there are three words. The first, belief, is a sort of epistemic uncertainty. The second, the American, is a sort of probabilistic, and the tall is a sort of fuzzy uncertainty of knowledge. I hope you have understood the difference between various types of uncertainties which we may encounter, and these uncertainties appear in the language which is used to express our ideas, which is further conveyed to the machine, and these uncertainties have to be conveyed to the machine in a language which is understandable to the machine, and machine understands mathematical concepts, operations, relations, functions, etc. So with this, next we go to the next slide, please. In this talk, please continue looking at the slide. We will be discussing the intrinsic concept of fuzziness with examples. Then we will be discussing fuzzy rule. Then I have already explained why fuzzy. Then definition and example of fuzzy sets. Then we will discuss operations on fuzzy sets similar to crisp sets, and the new type of operations on fuzzy sets, and then we will discuss what is meant by fuzzy relation, then we will discuss what is meant by fuzzy logic. And with this, friends, if the time permits, we will go to other type of uncertainty handling mechanisms. For example, we will discuss, if the time permits, in the two lectures, that how the doctors diagnose. The reasoning used by doctors is abductive reasoning. Now, how we make a concept, like we say a cow, how the concept of cow is formed. Similarly, we will frame other concepts also. And with this introduction, now I come to, first of all, discussion of fuzzy concepts, relations, functions, etc., which surround the concept of fuzzy. So friends, first of all, I gave examples of sweet, I gave example of tall, I gave some other examples also. I told that each of the words is actually not standing for something certain, but a large number of things. Think other words of natural language. Healthy. Now first of all, it is very difficult for us to tell who is healthy, what are the parameters of health. Then even if we know the parameters of health, we don't know what values are exact values by which we can say a particular person is healthy or not. So healthy actually incorporates a very wide spectrum of concepts, in which the temperature, the blood pressure, and so many other entities, the functioning of the heart, the functioning of the kidney, the functioning of the liver, all these vary from person to person. But within a range, if the values are there, if the heartbeat is within some particular range, if the blood pressure is within certain range, I underline the word range, not a particular specific value. So when a range is there, which stands as a value for a person to be healthy, then it becomes not a precise concept but imprecise one. Similarly, old, young. Now when a person is, say, below 20 years, we say yes, the person is young. A person who is, say, about 70 years old, we may say with definite the person is old. But what about the people? If day by day we don't know when we have become from 20 years to 70 years, when we have actually become from young to old. It is not all of a sudden overnight or over one day or by just addition of one day one becomes, no, it is a gradation. So you cannot say that at 35 one becomes all of a sudden when one day is added becomes old from young. So these are some of the words. Next, sweet mango, I have told you. Again, if you take a cup of milk and put one small sugar cube, then you go on adding. And after, say, 100 small cubes are added, small particle cubes, it becomes sweet. But it is not the 100th, the last particle cube, because of which it has become sweet. No, the sweetness has increased gradually with addition of each particle. Similarly, beautiful painting, it is hot and humid. We cannot say when it becomes hot exactly when it crosses 40 degrees. From 20 degrees centigrade to 40 degrees centigrade, the hotness increases gradually. So hot world indicates a wide range of temperatures, maybe say from 30 onwards or like that. But you cannot say just by addition of 1 degree something becomes hot. No, it is gradual increase in the value of hot. The vegetable is not properly cooked. Now, the not properly again is an uncertain word. So friends, I told you how the uncertainty of language appears in our thinking. Now the next step is, in the case of classical set theory, either a person is young or not young, either the milk is hot or not hot, either a person is beautiful or not beautiful, because in classical set theory, which we call crisp set theory, either an element is a member of a set or not a member of set. So the conventional or crisp set theory is not able to handle such concepts as healthy, old, sweet, etc., etc. So we'll have to find out the alternatives. And what may be the possible alternatives? This is fuzzy set theory, relations, function, etc. are just providing a tool or mechanism to handle this type of entities like healthy, old, etc. with mathematical tools. And what are the mathematical machinery or tools developed for the purpose of handling such imprecise concepts? That is, instead of assigning only two values for an element so far as its belonging to a particular set is concerned, belongs to, and the second value is not belongs to, instead of these two values only, we say that instead of assigning just two values, which you may call 0 or 1 also, we assign a range of values in the range of 0 to 1. When old is under consideration and if a person is of age 70 or above, we assign a value 1. That yes, definitely the person with an age of 70 or above is an old person. Again, if we take a person of 20 years old, we assign a value 0. That is, according to the common usage, a person of age 20 or below is definitely not old. So in this case we assign a value 0 to a person so far as oldness is concerned of age less than or equal to 20. And then we gradually increase the values in the range of 0 to 1. Instead of saying old and not old, we say a person has a degree of oldness in the range of 0 to 1. For example, a person of 30 years may be assigned a value of 0.2. A person of age 40 may be assigned a value of say 0.45. A person of age of 50 may be assigned a value of 0.7. So in this way, the fuzzy set theory handles the linguistic variables which I told are essential component of our everyday language, which appear in the problems which we encounter and in the solutions which we propose. I hope now you understand why we study fuzzy logic. Please look at the next slide. I take some other examples. These were not healthy, etc. were not the, even the range of values which were denoted by some other phrases like for a long period. You will see that the word long period may stand for from 6 hours to millions of years. Dinosaurs ruled the earth for a long period, and here for a long period, the phrase for a long period stands for millions of years. In the second, it has not rained for a long period. Again, for a long period is appearing in this second sentence also, but this for a long period doesn't stand for millions of years. It may stand only say about 6 months. And I had to wait for the doctor for a long period. And here it can't be even for 6 months. Nobody waits in a doctor's room for 6 hours, 6 months. Rather it may be 6 hours. So friends, what I want to convey to you is that not only the adjectives but other phrases also have different values, and the values may vary from a few hours to millions of years depending upon the context. So one of the ways of resolving the ambiguity, the uncertainty, the imprecision about a particular phrase is the context. When it is being talked about the dinosaurs, in that case it may be standing for millions of years. When it is talked about rain, it may be a couple of months. But when it is in context of waiting in a doctor's room, it may be standing only for a few hours. So we human beings have the strength of resolving this ambiguity or imprecision depending upon the context. Now how to embed this in the machine, as I told you just now, is through the use of range of values from 0 to 1, as I explained in the case of tall. Okay. Please look at the next slide. Not only it is fuzziness is only in the linguistics, even the fuzzy rules. Please look at the slide. If an obstacle is close, then apply brakes immediately. Here the two words, close and immediately, are not precise. If the vehicle is running very fast, maybe say 100 kilometers per hour, even 50 meters or less may be close. However, when we are moving on a bicycle, even 2 or 3 meters may be close, and beyond that may not be thought of as close. What do you mean by immediately? Again, immediately may mean a few seconds, or it may mean a few minutes, or it may mean even more than that, depending upon the context again. So what I mean to say, it is not on the linguistic variables which are appearing on the statements. These may appear also in the rules which we use in our everyday context of solving problems. One very strange thing which we'll find out is that we human beings are really very good when we talk in terms of imprecise concepts. Rather, sometimes we are baffled if too much precision is embedded in our talks. For this purpose, let us take an example. Please look at the slide. The slide says, please look at the slide. On the slide we find partially clouded sky, then saying 39.77% of the sky is covered. I request you to look at the slide, please. The slide says that we prefer the statement that the sky is partially clouded, instead of saying that the sky is 39.77% covered. What does this indicate? Though the partially clouded is having imprecision, it is not a very precise phrase. It is much less precise as compared to 39.77. However, if somebody says that the sky cover, cloud cover is 39.77, we may not get the intended meaning at all. However, instead of that partially clouded is used, we get the intended meaning. What I mean to convey here is that most of the time, we the human beings feel more comfortable when imprecise words or phrases are used as compared to precise numbers or figures. I hope this idea is very clear. Now, but on the other hand, the computers are comfortable with precisions. That is what it means in other words is that the human beings are better at qualitative processing, where the machines are better in quantitative processing. Whenever the precision is there, the precise numbers are there, even if these involve 10 places after the definition, the decimal, still the computer will be not baffled. But we human beings are baffled if something says that the sky cover is 39.76543, etc., etc. It becomes more and more difficult if more and more precision is embedded in our statements. It is a paradox. And now, what is the implications of this? The implication is, as I mentioned in the very beginning, that it is not the computer system which solves the problem. It is not the human beings which solve the problem. I again recapitulate what I said earlier, that the problems are encountered and perceived by human beings, number one. Number two, the plan of the solution of the problems are again thought of by human beings. These two parts are handled by the human beings. On the other hand, the third part is handled by the machine, that is the execution of the plan because of its speed. The computers have marvelous speed. What is its implication in context of what I said just now? I just now said, we human beings feel comfortable with imprecise statements. The machine is very comfortable, or whatever is good at processing when it is precise statements are used. So what is there is a gap in the underlying capabilities of machine and man. How to bridge that gap? That is, the human being think of the plan, they think in a natural way in terms of imprecise words and phrases, etc. On the other hand, these ideas have to be conveyed to the machine, because machine is very fast in executing the solution, which is good at processing exact entities, quantities. And for that, one of the via medias, there are various via medias which have been found out to bridge the gap of imprecision-based quality of human beings and precision-based qualities of machine. Through one of the tools or techniques or mechanism is fuzzy logic, fuzzy sets, fuzzy reasoning, fuzzy relations, etc. So repeatedly I am telling you, what is the significance of study of fuzzy? So next slide please. I have given more examples on the slide where I reiterate that human beings are good with imprecision, where the machines are good at precision. Just by looking at the eyes only or nose only, we may recognize a person. Just by taking and feeling a small number of grains from the cooking rice, we can tell whether the rice is properly cooked or not. Just again it is imprecise. Sometimes only the rice which you take may be well cooked, but the rest of the rice may not be cooked well. But in most of the situations, it works well. So here again, what I mean to say, that it is the imprecision on the basis of which we work or solve problems most of the time. However, these solutions are generally good solutions, may not be perfect solutions. There is a difference. The machines, if they give a solution, will be a perfect solution, whereas we human beings, which work most of the intuitions, are able to give good solutions in most of the situations, but may not be the perfect solutions. I am emphasizing repeatedly the importance of study of fuzzy concepts and all that. Okay, please. Next. Well, we may skip some of the slides. Well, again, the concept of number, the concept of set, and all these are precise concepts which we used in expressing our problems to the computer system so that it solves the problem in terms of its strengths. And the strengths of the computer are precise entities, the numbers, the sets, the relations, functions, which I am talking in terms of crisp sets. Crisp sets are those sets where if you take any element in the universe, you only can say either it belongs to it or does not belong to it. However, as I mentioned, generally we don't do like that in our everyday life. A tall person may be having any height from 5 feet 10 inches to anything if we take, say, Indian standards of tallness. So again, how to convert the entities which are imprecise in terms of numbers and sets of crisp sets which are precise in nature. So this is what we will be discussing in the rest of the lectures. You may have an example of a precise statement and imprecise statement. Once again, in order to know the difference between what is precise and what is imprecise, if income is more than 2.5 lakhs, then the tax is at the rate of say 10%. Whereas the imprecise statement may be of the form, if the forecast about the rain being slightly less than the previous year is believed, then there is around 30% probability that the economy suffer. You can see the second statement, the forecast in itself is imprecise, then is believed, as I told you, the belief's degree. Somebody may believe something completely, somebody else may not believe more than say partially, and so on and so forth. And then the 30% probability. What does this 30% probability means? That on the basis of the previous experience, having taken statistics of hundreds of years, we know if the rain is less than 30%, then the average, then it may be damaging to the crops, etc. So everything in the second statement is having imprecision, but we human beings are very good still in working out a solution. Whereas in the earlier statement, if the income is more than 2.5 lakhs, then the income tax is at the rate of 10%. Everything is very precise because those are in terms of the numbers, sets, relation, functions of the crisp nature. So with this emphasis between the precision and imprecision, the basic qualities of the machine as the human beings, we go to now the next statements. In order to explain the fuzziness involved in the linguistic variables, we will take help, as I mentioned, of the crisp sets. So how do we do? How do we go about it? Though I mentioned earlier, but still, just for further illustration, I again explain how the imprecise concept of tall will be expressed in terms of precise concepts of sets, membership, numbers, etc. Please look at the imprecise concept of tall. We can say that a person is definitely tall if the height is more than 6 feet, not at all tall if the height is less than 5 feet. We are talking in context, Indian context. If the height is 5 feet 2 inches, then the person may be said to be a little bit tall. If the height is equal to 5 feet 6 inches, we may say slightly tall. If the height is 5 feet 9 inches, we may say the person is reasonably tall. Now again, in this description, we have used natural language words. Definitely, not at all, a little bit, slightly tall, reasonably tall. Now what is the next? At least we know some difference, qualitative differences between definitely, not at all, a little bit, slightly, reasonably. We know the qualitative difference between these. Now how to express this in terms of mathematical entities? We can convert these linguistic imprecise words, though relatively comparable. You know, definitely is always taken more than reasonably. Reasonably is taken always more than slightly. Slightly is taken more than a little bit, and a little bit is taken more than not at all. And so we have already a sort of comparison relation between these words. Now once we have intuitive feeling about this, we can convert it to the mathematical numbers. The next problem is not very difficult, as you can see. Now what we can do? We can say that a little bit may be taken as 0.2. A slightly tall may be taken as 0.4 in the range of 0 to 1. That is when a person is not at all tall, if the person is less than 5 feet, we can say the value assigned so far as tallness of a particular person is concerned is 0. But when we are saying a person is about 5 feet 2 inches, and we, according to our definition, we say the person is a little bit tall. So we can, but little bit is more than not at all, and therefore the value to be assigned to of tallness to a person who is a little bit tall should be more than the value which is assigned to a person who is not at all tall. And not at all tall has been assigned a value 0, therefore a little bit tall person should be assigned a value which is greater than. And we say hypothetically, not a very precise, in every situation, we may say that the value which we associate with a little bit tall may be assigned as 0.2. Maybe I am saying. And when a person is say of 5 feet 5 inches, and according to our criteria the person is called to be slightly tall. And in that case we can say the value which is to be assigned to a person which is slightly tall should be more than a person who is a little bit tall, and the value may be assigned more than 0.2, and in this case we assume that let it be 0.4. Then what is then a person is say 5 foot 7 inches, and we call a person is reasonably tall. And a reasonably tall person is better than or having more height than a person who is slightly tall. And a person who is called slightly tall has been assigned a value of 0.4. So we may assign some value greater than the value which is assigned to the linguistic variable slightly tall, which was 0.4. Let us assign a value of 0.7 and so on and so forth. So friends, first of all, I have discussed the mechanism of how to convert linguistic variables to precise numbers and sets. As the word tall is an imprecise word, but then it has been further categorized into, according to the heights, as not at all tall, a little bit tall, and so on and so forth. And then there is a gradation between these linguistic words, not at all, slightly, reasonably, definitely, and that gradation should be preserved in terms of numbers of the range of 0 to 1. This is the mechanism which is followed in converting imprecise words of natural language to precise numbers and sets. Then we'll see. We have already the operations of intersection, union, complementation, etc. on crisp sets. The normal sets which you have studied up to 10th class or 10 plus 12, 2 class, now will be given a different number, that is crisp sets, in order to distinguish them from the fuzzy sets. And then we'll see how the fuzzy sets are described in terms of the crisp sets. So we'll carry on our discussion in the next second half after 15 minutes or so. Okay, thank you.